Hello, Trig class. This video starts the lectures about Chapter 8. And we already, of course, studied Chapter 7. And the good news about Section 8.1 is it doesn't have any new formulas on it. We're just going to do new things with some formulas we've already learned. So, as this handout says, we're going to talk about identities we've already seen, starting with what it's calling the reciprocal identities. So the reciprocal identities on this sheet were these, that cosecant is 1 over sine, and secant is 1 over cosine, and cotangent is 1 over tangent. So we've seen them before, but they might be useful in the section that we're about to do. We also had quotient identities that we talked about. And on our sheet, these were the quotient identities that we needed to know. Tangent is sine over cosine, and cotangent is cosine over sine. Okay. We also had the cofunction identities. And on the sheet, that's these. There's 6 trig functions, so there's 6 cofunction identities. And I did talk about these in the last chapter. And I actually would not memorize all these. You can just draw a triangle, and in that triangle make one of the angles x. One of the angles will be 90 degrees and the other will be pi over 2 minus x. And if you just write down in terms of the triangle that cosine is adjacent over hypotenuse, if you take a look at the sine of the other angle and you look at its opposite divided by its hypotenuse, they're going to be the same thing. So these are all true. You could memorize them if you wanted to, but on the other hand, you could also just draw a triangle and measure the 2 non-right angles as different trig functions, and this will become a true statement. I'll show you what I mean if we come across it. All right, you have to know the periods. And on the sheet, these were our periods. Secant, cosecant, tangent, well, secant, cosecant, cosine, and sine. They all have period 2 pi over b. So if you make the b equal to 1, that means they all have the period of 2 pi. So we've already talked about that. And tangent and cotangent, they have period pi over b. So if the b is 1, then their period is pi. So we've also done those. We've talked about the even and odd identities. And on our formula sheet that I made out so that people could remember things for test 1, which was on chapter 7, these are the even and odd identities. Sine is an odd function, cosine is an even function. And then there's the Pythagorean identities, which we did not identify as such, but all the information that we need is on the reference sheet already. That uses this information. So if you have a right triangle, then you have the hypotenuse. Let's say you make the hypotenuse 1. We'll call this theta. This will be the opposite side. This will be the adjacent side. And I made the hypotenuse equal to 1. Okay. Well, cosine, as we know, is adjacent divided by hypotenuse. But the hypotenuse is 1, so this is just saying that in a triangle that has a hypotenuse of 1, the adjacent side is equal to the cosine function. And the sine is always opposite divided by hypotenuse. But in this triangle, hypotenuse is 1, so it's just opposite. So I could relabel the opposite side as just sine theta, and the adjacent side is just cosine theta if the hypotenuse is 1 like it is in the picture. And that's what I'm going to do. Opposite side is sine of theta. Adjacent side is cosine of theta. And then we know from Pythagorean's theorem that this side squared plus this side squared equals that side squared. So in other words, cosine squared theta plus sine squared theta is equal to 1. That's one of the Pythagorean identities. If you take that one and you divide the whole thing by cosine squared, then you get a new identity. Cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tangent squared. And 1 over cosine squared is secant squared. So this is the second of the 3 Pythagorean identities. On the other hand, if you also start where we started with the first one again, cosine squared theta plus sine squared theta equals 1, and you divide everything by sine squared, you get a different expression that's just as valid as the other two. Cosine squared divided by sine squared is cotangent squared. Sine squared divided by sine squared is 1. And 1 divided by sine squared is cosecant squared. So there's 3 Pythagorean identities, but they really all just come from the fact that cosine squared plus sine squared is 1. Okay, so that's a review of the identities and formulas we've already seen. So where's the new part? What are we doing different in this section? Well, what we're doing is we're going to simplify trig expressions, and we're also going to verify trig identities. That's what we're going to get out of this. Okay, so let's start working on simplifying trig expressions. The way you simplify a trig expression is not that different than what's being called here the guidelines for verifying trig identities. So because the strategy is the same whether you're simplifying or verifying a trig identity, I'm going to write these out before we go up here. If you have an identity, the first thing you should do is try to turn the complicated looking side into the easier looking side, because it's easier to manipulate something complicated to something simple than to turn something simple into something complicated. So what you want to do first is try to turn the complicated side into the simpler side. And the common ways to get going on that is by doing algebra. Such as factoring or forming a common denominator. Now, verifying a trig identity is different than simplifying a trig expression, because when you verify a trig identity, you have a left and a right side of an equation. This is about equations. Equations have an equal sign, a left side and a right side. Expressions do not have an equal sign. They're just expressions. So when we're trying to simplify, we can't work on two different sides. There's only one side to have. There is no other side. But the part that's in common is the first thing you should do, whether you are simplifying a trig expression or verifying a trig identity, is do algebra, such as factoring or forming a common denominator. Okay, now maybe that doesn't work. So usually the next thing you'd try is, if you're stuck, if so, you can try to use other trig identities. Let's suppose you're still stuck. What can you do next? So the last thing you could try is try switching everything to sines and cosines. Then retry step 1 and 2. So that's your strategy, whether it's simplifying a trig expression or verifying a trig identity. Do some algebra, such as factoring or forming a common denominator. When you do that, well, if you could factor something, try factoring it. Do you not have a common denominator? Make a common denominator. And then if that doesn't work, you try to use other trig identities. And if that doesn't work, you can try switching everything to sines and cosines. All right, so let's try that on this guy. Now, this has no denominator, so there's no such thing as forming a common denominator the way it is. And also the way it is, nothing factors out. So if nothing factors out and you can't form a common denominator, you can try using a trig identity. A trig identity for tangent is that it's sine over cosine. So we're going to use the fact that it's sine over cosine. And we'll use that in the next video. See you there.